us to show you this program's hands-on activity.
You can download the Educator Guide and a list of materials from the NASA Connect website.
Here are the main objectives.
Students will gather statistical data, find the optimum ratio for best vehicle performance, explore mathematical problem solving, and explore mathematical models through graphing.
Here are some terms you need to know.
Propulsion is the act of driving forward or away. Thrust is a force produced by a rocket engine in reaction to high-velocity exhaust gas. Kinetic energy is energy in motion, and momentum is a directional measurement of an object's motion, its tendency to continue moving in a particular direction.
Good morning, class.
Good morning, Ms. Smith.
Today, NASA has asked us to gather statistical data so that we can determine the optimum ratio of our VSV rocket.
Students will organize into groups of 4, with each student taking on one of 4 jobs as pre-launch officer, launch officer, data recorder, and measurement technician. Roles can be rotated after every trial. Each group will construct the launch facility by placing 20 meters of masking tape on the ground in a straight line. Divide the length of masking tape into 10-centimeter intervals. Place the shoebox at one end of the masking tape. The rocket will be placed against it each time. It may be necessary for the pre-launch officer in the group to place gravel or dirt inside the box to stabilize it. Begin testing by using a push pin to attach a 2-centimeter baking soda packet to the bottom of the cork. The directions to assemble the baking soda packet can be found in the Educator Guide. Remember, each rocket must be filled with 115 milliliters of vinegar.
Trying to get vinegar all over yourself.
Slide the cork with the baking soda packet attached into the neck of the bottle firmly. The launch officer will rapidly shake the rocket 3 times to start the reaction of the baking soda and vinegar. Quickly place the corked end of the rocket against the shoebox and move away.
Booster ignition and liftoff.
The measurement technician will call out the distance traveled by the rocket, and the data recorder will write the distance on the distance data chart. The pre-launch officer will then prepare the rocket for the next trial. Repeat until all trials have been completed. Each group will plot the data onto a graph using a different color for each group. Students will compare the group's average data and analyze the shape of the graph to determine the best ratio of baking soda to vinegar.
All right, class, in comparing the data, at what point did the recorded data start increasing? Erica?
It started increasing immediately.
Why would it be important for us to find the optimum amount of fuel to use for any rocket? Aaron?
Because you don't want to carry more or less than you need.
Teachers, if you would like help with the baking soda rocket lesson, simply enlist the help of your AIAA mentor, who will be glad to help your class with these activities. AIAA stands for American Institute of Aeronautics and Astronautics. Boy, those kids looked like they were having fun. No, Jennifer, I did not say having a blast, but I wanted to. The folks at NASA Marshall have an awesome program for next generation explorers to get a real feel for rocket science. It's called the Student Launch Initiative, SLI, just like the Space Launch Initiative. Initiative is the key word because these students design, build, test, launch, and reuse a rocket carrying a half-pound experiment. They experience the thrill of seeing their rockets take off and soar from 1.5 to over 3 kilometers high.
Ascent is good.
Students from Huntsville area high schools and universities participated in NASA's first Student Launch Initiative. The students use math, science, and technology to design and build their rockets, to develop websites, and to apply budgeting and planning principles.
5, 4, 3, 2, 1. Igniter. Ascent is good.